Welcome to our Mathcast on solving equations with variables on both sides. Our goal is to help you better understand the concepts at hand when you need it and at your own pace. We hope you enjoy this Mathcast on solving equations with variables on both sides. To solve a problem with variables on both sides, you have to get all variables on the same side. So to do that, you must do the opposite operation of the variable on both sides of the equal sign so it cancels out. As you see here, the problem we are solving is 2a plus 3 equals 3a plus 10. So let's go back to what we explained before to get 2a and 3a on the same side of the equal sign. To do that, you subtract 3a from both sides of the equal sign. Since negative 3a cancels out our positive 3a, our new problem is 2a plus 3 minus 3a equals 10. Now we must combine like terms, which comes out to negative a plus 3 equals 10.
Now we can finish the problem. Please know, there are many other ways than the way we are doing to solve this equation, but we are going to show you this specific way. The first thing you have to do is get negative a alone. You must do the inverse operation of plus 3 to both sides of the equal sign. So now, after you subtract 3 from both sides, your new problem is negative a plus 7. But we're not done quite yet. The last thing we must do to solve this equation is you have to get a alone. So to do that, you have to divide negative 1 from both sides because negative a is just like negative 1a. Now we have solved for a. Our solution for a is negative 7.
Now that we know how to solve with variables on both sides, we can move to a more complex equation. So this more complex equation is negative 2x minus x plus 9 equals 3x minus 9. Now we do the inverse operation of 3x to both sides of the equal sign, so then it will cancel out. So our new problem is negative 2x minus x plus 9 minus 3x equals negative 9. Now we combine like terms and get negative 6x plus 9 equals negative 9. Now we need to do the inverse operation of plus 9 to both sides of the equal sign to get a new problem of negative 6x equals negative 18. So we now need to get x alone, and to do that, we must divide each side of the equal sign by negative 6. Now the solution to this equation is x equals 3.
Sometimes you'll run into a problem that will have multiple fractions. There is a quick and easy way to resolve this problem. All you must do is get all numbers with the same denominator. So in this case, all numbers except 1 has a denominator of 5. To get them all to the same denominator, we have to find the lowest common multiple of all the denominators and multiply the current denominator with the number that you will get to find said lowest common denominator. In this case, it is 5, because the number with the denominator is 5 is 1. Now if we multiply 3 by 5, then you get 15 fifths. So our new problem is 2x fifths plus 15 fifths minus 4x fifths equals 1 fifth. Now, since we have all of the simplified denominators, we can cross them out and only use the numerators. So our new final simplified equation on this slide is 2x plus 15 minus 4x equals 1.
Now we have a problem that we all know how to solve. First, we must combine like terms and come out with a problem that is negative 2x plus 15 equals 1. After that, we must do the inverse operation of plus 15 to both sides of the equal sign to get another new problem that is negative 2x equals negative 14. Now we divide negative 2 to both sides to get x alone and get a final solution of x equals 7.
Sometimes a problem will erupt and look like this. To find the area, we must find x, and to find x, we must create an equation with variables on both sides. How do we do that, you may ask? Well, since both polygons' perimeters are equal to each other, all we must do is simplify each polygon's perimeter and put that perimeter on the other side of the equal sign of the other polygon's perimeter. So let us simplify the rectangle first. To help us visualize the perimeter better, we can write the rest of the perimeter around the rectangle. Now that we have this, we can account for all x's and add up all numbers to get a final expression of 4x plus 4. Now, onto the triangle. First, write out the whole perimeter as so. Then, combine like terms to come out with an expression of 3x plus 10. And now we have an equation to solve. That is 4x plus 4 equals 3x plus 10.
Now that we have an expression to solve x, we are many steps closer to finding the perimeter of the two polygons. So now let's do the inverse operation of 3x to both sides of the equal sign to get a new equation of x plus 4 equals 10. Now do the inverse operation of plus 4 to both sides of the equal sign to get x alone and solve the equation. So x equals 6. But we are not done yet. We must plug in x to each perimeter. And when you plug in x, they both equal the same amount and equal 28 units because there is no unit of measurement given.
Sadly, this is our last equation. But this one is a little different from any other equation. But we will have to get further in the problem to see what is different. Since there are so many w's this time on each side of the equal sign, let us simplify all the w's to get a new equation of 0w equals 0w plus 15. And when you simplify it again, it comes out to 0w equals 15. But what in the universe is 0 equals 15? So in this case, there is no possible answer to w. So the answer you should put is no solution. Thank you for watching this Mathcast on solving equations with variables on both sides. Please feel free to listen and learn from other Mathcasts on this channel.